Hey everyone, good afternoon. Thank you for joining us during your lunch, or hopefully you're skipping your lunch to check us out here. First time I've presented in a movie theater. Too bad we're not doing like Avengers Endgame. That would be a pretty cool session. But we're here to actually talk about a partnership between SAP, Google, and Intel, specifically around a technology called Intel Optane DC persistent memory. I'm Jack Vargas. I'm one of the product managers at Intel working on this technology. Soon in the next couple of sessions, I'll be joined by my friends, Tim, Andreas, and Rohit. So to give you an overview about why we're here and what we're talking about, I'll spend the first section talking a bit about the history of this journey, what this technology is about, why we're even doing it. Then Tim will come up, talk about SAP HANA, and then Andreas and Rohit will join us for the final session. We plan to have a couple minutes for Q&A. I know it's kind of dark, but there are some mics up here on this second row here, so if you have any questions, just head on down, and we'll take your questions toward the end of it. All right, so first I want to talk about this journey that Intel's been on. We've been working on this technology for the past 10 years, and really the last 6 of that has been in deep engineering collaboration with SAP, specifically optimizing SAP HANA to take advantage of this new technology category called persistent memory. Now, in the last couple of years have been really exciting for the partners listed up here. So actually 2 years ago, SAP was the very first company to demo persistent memory live at SAP Sapphire. And then this past fall, during an Intel event, we gave Bart Sano, who is a VP at Google Cloud, the very first production DIM of this Intel Optane DC persistent memory. And that kind of started a slew of activities working with SAP, Google partners to really start prototyping and doing POCs around this technology. And then actually just a week ago, Intel officially launched this Intel Optane DC persistent memory general availability along with our second generation of Intel Xeon Scalable processor. Now, why is Intel, why are these companies kind of rallying behind this technology? You know, what's the big deal? What's going on? And it really has to do with data. So in the short now 6 years, in 2025, we're expected to generate 175 zettabytes of data compared to 33 zettabytes generated in the last year. You know, current technologies aren't really equipped to make that data useful to the industries, your customers, your partners. So let's explore, you know, kind of why that is to give you a fundamental knowledge of why this technology is going to change computer architecture as we know it. So here's kind of the classical pyramid diagram of current technologies when it comes to memory and storage. Now you may notice there are big gaps between these, and in the realm of computer architectures, these are oceans away. So at the very top we have memory, which currently the mainstay is DRAM memory. So this is tiny capacities compared to what you can see in solid-state devices. It can be relatively expensive, but it's really fast. We actually measure latency in nanoseconds within this realm. Now we cross the gap and we enter the storage realm, which currently the 2 main technologies are flash, NAND, SSDs, and then as well as spinning magnetic disks like hard drives or even tape. Typically, latency measured in these are within the realm of microseconds, so again, a magnitude different than what we can have with the memory. Though in the storage realm, they have higher capacities, they're fairly affordable for the gigabyte per cost. But again, they're a magnitude different in performance. So this bottleneck has actually been in computer architecture for quite some time, where actually software has really just worked around this by really optimizing code to make advantage of it. Now how we're changing this equation is by this new technology called Intel Optane DC persistent memory. Really the first mainstream persistent memory technology that's coming to the marketplace. So this is big, affordable, as well as the data on it can be persistent even after a server reboot, a power loss, etc. We're coming to market with a 128, 256, and 512, and actually in my pocket I have one of our 512 capacities right here. So with these, you can have a total of 6 of these on a second generation Xeon processor platform, and you pair those with a DRAM. So on one socket, 6 of these. On a standard 2-socket server, you can have up to 12. So if you take the 512, multiply that by 12, you have a total of 6 terabytes of persistent memory available on your platform. Now, also, I will mention that since now in the memory realm, data is at rest, security is quite important. So these actually come in with standard hardware encryption. All right, now I'm going to give just a quick download of how we actually use this technology. So there are specifically two operating modes. So think of one as being persistent memory, and I'll get into details of how you can use that. And the other one is actually kind of our easy way to take advantage of that large memory footprint, but without the persistency, and we call that memory mode. So let me talk about app direct mode. So in app direct mode, this technology is transparent to your operating system, your users, your application. And smart ISVs, independent software vendors like SAP, who understand their data structures very well, will put the data structures which make the most sense in the medium that they have available. So for those data structures that make the most sense in DRAM, where you need that high bandwidth, they can put the data structure there. But if you could utilize maybe a lot of persistent memory and take advantage of it being persistent, if I had to do a server patch or something, it's able to come up quickly versus previous generations. I will make note with App Direct, there is that usage, but there's actually a second usage where you can actually use standard storage APIs. So instead, if you wanted to just use standard block I/O or actually boot from the DIMMs itself, we do support that. Now with memory mode, how this is utilized is basically the platform is going to consume the DRAM in your system to act as a really fast write-back cache. So from an application standpoint, that 6 terabytes I mentioned before, it'll just see that 6 terabyte and won't see the DRAM behind that acting as a cache. So with this, again, this is a volatile usage, and really this is to be out of the box if you want to have 6 terabytes available of volatile memory. This is the route to go. Now, hopefully that's a quick 101 of Intel Optane DC persistent memory. I'll turn it over to my friend Tim now to talk about SAP HANA.
So I'm Tim Allen. I'm on the SAP account team. So SAP is the first major RDBMS to support Intel Optane persistent memory in app direct mode. Now, today it's kind of fitting. My name is Tim Allen. I used to do a little acting. We're in a movie theater. So I just made me think about my prior life. So when we think of Intel Optane DC persistent memory, this kind of fills in the blanks that Jack was talking about. As you can see, there's this new layer, persistent memory, that kind of bridges the gap between storage and memory. And like I said, SAP, we've been working on it for several years. It finally launched last week. So when you look at Intel Optane DC persistent memory, I look at HANA 2.3. HANA 2.3 was released prior to Sapphire last year. It was the first major database to support persistent memory. And now we have some specifics. Now, Andreas, I'm not going to talk about 2.4, but obviously we know that's imminently coming, soon. What? It was released last Friday. Okay, so it's imminent. It was released last Friday. So this file could be updated, but it's still the same. As I like to think of it, SAP has supported persistent memory for a long time, even before the product released. Okay. Now, a couple things to pull off this foil is with persistent memory, and this is just compared to the last generation or the first generation of Intel Xeon Platinum processor. For transactions, it supports up to 3x more capacity, and for analytics, it supports up to 6x. So I'll get into specifics of how that works here. Now, historically, at Intel, we've worked with SAP for over a decade on HANA. Each generation, we've added either new features in the Xeon processor level. As an example, about 3 or 4 years ago, we added a feature called TSX, which sped up by transactions by almost 500%. And that was the E7 v3 platform. And fast forward this year, we released the second generation of the Intel Xeon Platinum processor, and now we support persistent memory at the processor level. And so this kind of gives you a brief summary. Now, I know there's not a one-to-one mapping with GCP, but at least it tells you at the processor level, historically for transactions, what were some limitations. So if we look back to the E7 v4, we supported up to 3 terabytes per processor. With the last generation of the processor, we spread up everything by about 60% if you look at some of the SAP BW4 HANA benchmarks. However, we took half of the processor, or I should say, we took half of the DIMM slots away. So that's why you see it went down from 3 terabytes to 1.5. Well, with this one, you still have the same amount of DIMM slots as you did as the first generation of Intel Xeon Platinum processor, but now we support up to 4.5 terabytes per processor. And if you think about that, that's pretty powerful. So what does that say? On a 4-socket configuration, you can actually have 18 terabytes. Okay. So when I think of data management challenges, obviously we know our data always grows. There's always a consistent cost of, well, how do we manage it? What's our operational budget? And then how can we get answers and solve problems quicker for our customers? So decrease time to value. Now, when I think of persistent memory, I think it solves kind of this heat map issue. So traditionally, and Jack referred to this previously, you just had 3 tiers. You had your DRAM for your in-memory, and then for things, now I have to admit, another previous life, I used to be a DBA, and even within memory, you don't store everything in the in-memory database. So like your data, that's like your quarterly or monthly reports, you likely will put that in warm data, which is the orange represented here. And the blue data is for like your big data stuff that you'd store like in Cloud Data or something similar. Now with persistent memory and this larger capacity, what you see is kind of the emerging or a new zone, the second to the left there, the Intel Optane DC persistent memory zone, which has both the capacity to store warm and hot data. Now, when I think about this, what do I think about it at the database layer? Specifically, the main memory, or about 95% of your data, can now be stored in persistent memory. This also applies to potential new features that were added in HANA 2.3, like extension nodes. So that gives you an opportunity to put persistent memory both in the hot and the warm data tiers. Now, when I also think about persistent memory, we are driving the cost down of compute. Now, on HANA, when I think of a historical on-premise scenario, I'm hearing customers just last year were buying new systems, and they're telling me that about 60% of the cost of that system was just the memory cost. So we're going to drive down that cost with the DIMMs that we just released, and there's going to be better opportunities for business continuity, and this is a good place where GCP plays it. I'm hearing some customers that kind of have a hybrid scenario where they will still host locally in their data center, but they're going to use replication to do disaster recovery, for instance, to the Google Cloud. So that's something to think about in your scenario. And I already talked a little bit about increased memory capacity. Okay, so when we delve a little deeper, we're also seeing with this increased capacity an opportunity not just from a lower DIMM price perspective or price per gigabyte. There's opportunities to consolidate multiple instances. Intel IT in particular, we're actually in the process of consolidating both our ECC and another HANA native instance into one. So look for solutions we're discussing that in detail here in the next couple of weeks leading up to Sapphire. So the other thing I like to think about, and I alluded to this earlier, I called this the layer cake, but as you can see, this is a piece of cake that's fallen on its side. And now we have the area in green is where persistent memory falls into place, okay? That is your main data stores. Now, as Jack said to previously, you're still going to need some DRAM, but the vast majority of the HANA database in orange is where your main memory is going to be stored. So it's going to vary per customer, but rough estimates I'm hearing is between 96% of your data will now be in persistent memory. And that's going to improve your reloading of the database at startup. It's going to improve the time, the data load of that significantly. It's going to go from potentially up to an hour to minutes. The last thing I want to talk about is business continuity. Now, there's lots of things when you think of business continuity. The first thing I think of first and foremost is backup. As you can see, this actually shows an opportunity to introduce persistent memory into your existing environment, where you still have some older systems that just have all DRAM, and now you can do a replication scenario where you can use persistent memory on the right with the orange, the darker orange, with some DRAM, because you now have a bigger footprint. This can also be used for backup. This can be used for disaster recovery at a different location. It could be used on the Google Cloud as an example. And the last one is a new use case with extension nodes. So extension nodes was a new feature that was added in HANA 2.3. It does not replace dynamic tiering. That still exists, but it's a new feature that allows you to place your warm data into persistent memory, and that has a scaling factor of 8:1. In other words, you can have 8 times as much persistent memory in the dark orange as you have with DRAM. So look to SAP to get more details on how to implement that. The other thing nice with extension nodes is it gives you a full HANA instance for your warm data, and then that will give you full access to all the PAL libraries to do analytics. With that, I'll turn it over to Andreas.
Thanks a lot, Tim. So microphone is working. My name is Andreas Schuster. I flew here all the way from Waldorf, Germany, so I'm representing SAP in this long-standing cooperation between the 3 companies. I'm the product manager for persistent memory in SAP HANA. And before I get started and telling you a little bit more about how HANA is actually using it and what it means for HANA, let's briefly wrap up what we just heard. So we had Jack in the very beginning introducing the technology itself of Intel Optane DC persistent memory, this new, pretty nice, pretty exciting software technology, hardware technology. And we had Tim speaking about SAP HANA and a couple of use cases that we see how HANA can make use of that. So, but what does that actually mean for SAP HANA and for SAP HANA on GCP? So this is a pretty packed slide, I have to admit that, but it actually gives a pretty good outline of the use cases that we see and the benefits. So basically, the main benefit being you can actually process more data in real time, so at basically the same performance as if it was in real time in DRAM. The TCO is supposed to be much more better for you and for a company, so it's cheaper than traditional DRAM. And the one aspect that we haven't really touched so far is the improved business continuity. So the main differences between persistent memory and DRAM is not just size and cost, but it's also that it is persistent. So it means that it doesn't lose the data when you shut down the server or the database, which is something that, at some points you just have to do if you need to do maintenance. So for applying a database upgrade or an operating system upgrade, or just to, so you can actually imagine what that means for an in-memory database like HANA. So all the data is kept in main memory at all times to be able to process it, and to process it with the speed and the performance that you actually expect and that HANA is promising. But it also means that if you shut down the database, all the DRAM and data gets deallocated, given back to the operating system. And when the database is coming back up, the database, SAP HANA, needs to reload that from a persistent layer, which is, in the case of SAP HANA, just simple storage. Now, SAP is offering or positioning HANA in a big data environment, so for large amounts of data in the terabyte scale. And if you imagine, so no matter how fast your storage actually is, it takes some time. So if you need to load 6 terabytes of data from like an SSD, even if it's a very fast SSD, into main memory, this can take a considerable amount of time. So what we were able to achieve in this area is an improvement by a factor of 12.5. So it is based on a lab example. that we did before Sapphire last year. So we were able to reduce the startup time, including the data loading phase, from 15 minutes to just 4 minutes. So this means your database is basically going to be back much faster after the maintenance phase than it was before. And of course, SAP is also very proud that we, on the long-standing collaboration, so that we are actually able to announce that we are the first major database that is fully supporting that. We touched briefly the two operating modes of persistent memory before, so memory mode and app direct. Memory mode is basically you can run every application in memory mode, but to actually take full advantage of the technology, including the persistency aspects, that takes the app direct mode. And this is also, so we spend significant efforts in our engineering department to actually enable SAP HANA for that technology. And we got great assistance from Intel on that, by the way. Yeah, so basically summarizing that again, so you get reduced TCO and 4 times increase in density, so from 128 to 512 gigabyte. These are the ones that are available right now. And you can also, you have the potential to simplify your landscape. So we have seen a couple of examples before. Because you can make use of that capacity to, well, put in more data or just install 2 databases on one physical server or on one server in general. So it can, of course, also be virtualized. This, in some cases, allows you to actually avoid a scale-out scenario. So a scenario where you logically combine 2 servers to one. I mean, it's basically 2 servers. So you also, in terms of operating that, it becomes more complex. And you can, which is also a pretty good value proposition, is the aspect of data tiering. So persistent memory is not per se a data tiering technology. So that's not how it is positioned, and it also would not be fair to call it that, because the performance is actually not for warm data, so you don't have any performance difference if you keep data there. But it certainly has an influence on how you do data tiering, or whether you have to do data tiering in the first place. Because if, let's assume you have like 50% of your database size is warm data that you could actually move somewhere else. By using just DIMMs that are twice as large, you can just keep that in your hot tier. You have the same performance for the hot data. And what I think is even more important, you don't need to go through that whole project of actually identifying what data is warm, and you don't need to move the data. You can just leave it as it is. It is simpler from an operations perspective. And also basically might prevent you, or you don't need to add an additional system like dynamic tiering or a second, like another external cold data tier. I explained about the business continuity aspect already. So this 12.5 times improvement in restart times, or like data loading times at startup. This is, well, this lab example, we have actually proved that many times during the last year. So we've done a couple of POCs with customers, so real-life customer systems. And sometimes we've even seen much higher factors, so up to factor 21. Depends a little bit on the actual size of the database. So because, well, the larger your system is, the more time you save basically by not having to load that data, and the higher also the factor becomes. So on Google Cloud. So Google Cloud has also been a very, well, collaborative partner for Intel and SAP in the last year. And today, Google Cloud is actually the first public cloud provider to offer virtual machines that use persistent memory. So the instances that GCP is offering, it's a 96 vCPU, 7 terabyte virtual machine, so 7 terabyte combined DRAM and persistent memory, of which 80% is actually Optane, so persistent memory, a factor of 1 to 4. This basically brings you a higher overall capacity at a lower cost, or at the same cost as a smaller one. Then we should just compare that to a system with just DRAM. Okay, so I have to put a couple more numbers behind that promise that we make in terms of restart time, and to also show you how this actually works, or how HANA is designed, and what the startup time is actually composed of. So there are two components that are pretty stable. It's like the HANA shutdown and HANA startup. This is just to basically load the binaries and to shut down the software. So this stays pretty much the same, no matter what data size you have, and also whether you use DRAM or persistent memory. So there's not too much that you can actually improve there. But what is really, really important is the time that it takes you until your database is back for normal operations. So the time until you can use your database in the same way and with the same performance as you could before you shut down the database. And this is, here these bars on the very right one. So with persistent memory, in this case, it took 23 seconds compared to 280, which roughly corresponds to that factor that we've seen before. And this difference will, of course, increase the larger your systems get. So if you have HANA is available in sizes up to 24 terabyte for a single instance, so you can expect even larger improvements if you're actually running a system in that size. Yeah, so this slide is actually very similar from what it tries to tell. So how the downtime of a typical SAP system actually looks like. So there's typically a phase where you prepare your downtime in the very beginning. So you prepare the application to actually make it ready and to tell it, the database is soon going to be shut down. Takes a couple minutes, so that's actually not too long. And then there's, in this slide, there's a pretty large downtime of 45 minutes. So this is actually the maintenance task that you need to execute on your database. The duration of that, of course, varies. So 45 minutes is also already a pretty large one. So like an operating system upgrade or a HANA database upgrade. It's also a time that you cannot really avoid. So this is just what it takes to get ready. And then the interesting part is when you start to host again. So you see on the upper bar shows persistent memory, Optane. Where after just like 4 minutes after you instantiate or basically reinstantiate the database, it is back with the same performance as it was before. If you compare that to how it looks with DRAM, in this case, so the data when it's loaded is of course prioritized. So the most important data is loaded first, so that your system can go back as fast as possible. So for 34 minutes. It takes, in this case, to get 2.5 terabyte ready with the most important tables, so that your system can go back to actually serve your queries. But the time it takes for the full 5 terabyte is even longer. So in this case, almost an hour. So you can imagine what that actually means for your system. And with this, I'd like to hand over to Rohit, who will tell a little bit more about the roadmap.
Thank you, Andreas. So here, just to give you guys a quick overview of Google's journey on providing system sizes. Google has been true to providing all the systems as virtual machines so far. So you'll see on the roadmap when we started off back in 2017 was the first HANA system that was 208 gig of memory. And we have come a long way. Now, if you look at Q4 2018, we're able to release up to a 4 terabyte single node machine that's available. And now with the partnership from SAP and Intel and Google, now we're able to release the first 7 terabyte system that's running on Optane memory. And further down the roadmap, you'll see couple of months down the road, we will be releasing the 6 terabyte and the 12 terabyte, again, single node virtual machines that will be available to run HANA as single node scale up mode. And then around the end of the year, we will be releasing the 18 terabyte VM again. So to conclude today, thanks to Intel and SAP to introduce you folks to the Intel Optane DC memory, persistent memory, based HANA systems that will be available in Google Cloud. We have information available. Further information, you can always contact Tim, Andreas, and Zach for further questions.